Hey guys, this is homework 7.6 on simplifying rational expressions. Simplifying rational expressions is really just simplifying fractions, except now we might have expressions in the numerator and denominator instead of just whole numbers. So we really have to use our factoring skills to simplify these rational expressions. We need to remember that when we simplify a fraction, we should always be creating equivalent fractions. Okay, let's try example 1 together. So we have this fraction 18 over 12. So this is something we've done before. If we want to simplify this, we really just need to think of a number that goes into both 18 and 12 that we can divide out. So you might think of it this way: 18 divided by 6, 18 divided by 12, because that is the biggest number that goes into both 18 and 12. So if I divide 18 by 6, I get 3, and if I divide 12 by 6, I get 2. Another way of thinking of it that might be more helpful to us in simplifying rational expressions might be to think of it as 18 can be written another way as 6 times 3, and 12 can be written another way as 6 times 2. When you look at it like this, now you can see that we have a 6 being multiplied in the numerator and a 6 being multiplied in the denominator. So actually I could divide those 6's out and they just become 1, which leaves me with 3 over 2. This way of thinking of it might be a little bit more helpful in terms of simplifying rational expressions when we have expressions in the numerator and denominator. So let's take a look at an example like that. Okay, so with example 2 here, we have 4x squared y to the 8th, all divided by 20, x to the 10th, y to the 3rd. Now if you notice, we have expressions in the numerator and denominator, not just whole numbers. So if you notice specifically, though, in this example, we still have a monomial both in the numerator and in the denominator, meaning there's no addition or subtraction going on. So we can kind of think of it as I can divide whole numbers with whole numbers, I can divide variables that are the same, and I can divide other variables that are the same. So if you take a look, I see that the 4 and the 20 are both whole numbers, so I can reduce those. I see that the x squared and the x to the 10th have the same variables, so I can simplify those. And then I also see that the y to the 8th and the y to the 3rd are the same variable, so I can divide those as well. Okay, so if I divide the 4 and the 20, that will leave me with 1 over 5. If I divide the x squared and the x to the 10th, remember when I divide fractions, I actually subtract their exponents. However, in this case, since the x to the 10th is on the bottom, that means that whatever leftover x's I have, they should go to the bottom. So the difference between 10 and 2 is 8, which means that x to the 8th remains on the bottom. Now with the y's, I have y to the 8th and on the top and y to the 3rd on the bottom. So that means that there are basically 8 y's being multiplied together in the numerator and then 3 y's being multiplied together in the denominator. So that leaves me with 5 y's in the numerator. So that's y to the 5th. And since you see I have something else in the numerator there that's being multiplied with that 1, I actually don't have to write that 1. So I can just write y to the 5th over 5x to the 8th. Okay, not so bad so far. So now here's another example, example 3. And this example is x squared minus 9, all divided by 2x plus 6. So now if you notice, this is a bit different than the first two examples, because now we have binomials in the numerator and denominator. So I can't just kind of divide things out the way that I see them here, because they're attached by addition and subtraction. So really the only way I can go about dividing things out is if I factor the numerator and possibly the denominator, or anything that can be factored. Once I factor, then I can divide out things that are being multiplied. So let's do this example together. Okay, the top, I notice that it's a binomial, and I look for a GCF. X squared and 9 do not have a GCF in common. And since it's a binomial, I should look to use difference of perfect squares. So I'm going to ask myself if this is a difference of perfect squares, and I notice that x squared and 9 are both perfect squares, and the 9 is negative, so that fulfills the requirements. So I'm going to factor this out, and I get x minus 3 and x plus 3. Now in the bottom, again, I notice it's a binomial, first thing I always look for to use when I factor is GCF. And 2x and 6 do have a GCF of 2. So I'm going to take that 2 out, and then I'm going to write what's left, which is x plus 3. Now if you notice, the top is x minus 3 times x plus 3, and the bottom is 2 times x plus 3. Everything you see here that's in parentheses is a factor, and I can only divide out every part of that factor with the same factor. So for example, I can't just cross like this x right here out with this x on the bottom, because this x on the top is part of that binomial, and this x on the bottom is part of this binomial. So the only thing that I can do is if I see two factors that are exactly the same on the top and bottom, then I can divide those out. And I notice here that I have x plus 3 on the top and x plus 3 on the bottom, so these divide out to be 1. So that means that I'm left with x minus 3 on the top and 2 on the bottom. And even if the top was, let's say, x minus 4 or x minus 6, or had some number that was divisible by 2, I could not divide it out with that 2 on the bottom, because this binomial on the top is being held together by that subtraction. So the only way I could divide it out is if I had a factor that was exactly the same. Okay, here's one more example that I'm going to leave you with. So this example is x minus y divided by y minus x. So we want to simplify this fraction. So again, I can't just cross out the x's and cross out the y's, because they are being held together with addition and subtraction. So I can only really divide something out if it looks exactly the same, if it's a factor that's exactly the same. So one thing I'm going to help you out with is I'm going to rewrite the bottom so that the x is first and the y is second. So on the top I have this x minus y, and on the bottom I'm going to rewrite it. So I'm going to do negative x plus y. Okay, and I'm going to leave you with this to think about, and part of your homework in your Google form tonight is going to be to determine what this example 4 here, what this simplifies to. And the hint I'm going to give you is try substituting a number in for x and substituting a number in for y and seeing what it simplifies to. Okay guys, that's all for now.